Okay, so for the last lesson about correlation, we're going to study lesson number 9, and this is significance of the correlation coefficient. And in this lesson, we're going to test the computed correlation coefficient R through hypothesis testing if there is a significant relationship between the two variables. Okay, so by hypothesis testing, this is our procedure. Step 1, we're going to state the hypothesis. 2, find the critical values. 3, compute the test value. 4, make the decision. And lastly, summarize the results. So parang kagaya rin ito ng ating ginagawang procedure in one sample z-test and t-test. This is the traditional method of hypothesis testing. Now, here are the assumptions for testing the significance of the linear correlation coefficient. 1. The data are quantitative and are obtained from a simple random sample. The scatter plot shows that the data are approximately linearly related. So dapat pag tinat natin sa XY plane, makuha natin yung scatter plot, dapat may itsura naman ng relationship. Linearly related dapat yung dalawang variables. 3. There are no outliers in the data. Walang extremely low and walang extremely high. So one of the assumptions natin yun. And then variables x and y must come from normally distributed populations. And our hypothesis will be the null is rho equal to 0, which means there is no correlation between x and y variables in the population, meaning no significant relationship. Hindi related yung x and y variable. So before, ang ginagamit natin is for a population mean, we use mu equal to 0 for our null hypothesis, which means that there is no difference between the population mean and the sample mean. Dito, no correlation or no relationship. Before, ginagamit natin no difference. Okay? And for our alternative hypothesis, we have rho not equal to 0. Ibig sabihin, there is a significant correlation between the variables in the population, or there is a significant relationship between the variables in the population. Okay? Now, and the formula that we're going to use is t-test for the correlation coefficient. That is t equal to r square root of n minus 2 all over 1 minus r squared. Now, our degrees of freedom is n minus 2 kasi ordered pairs tayo. By rate data ito. So, instead of n minus 1, for our degrees of freedom na ginagawa natin for one sample t-test, for the correlation coefficient to test using t-test, we have degrees of freedom n minus 2. Okay? So I'm going to give you an examples on how to test if there is a significant relationship between the two variables. Thank you.